Hello and welcome to Sleepy Scientist. I'm glad you're here, whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight we're taking a slow, gliding journey into a place most of the world has never seen, not because it's far away, but because it's hidden. Picture this: you're standing at the edge of the vast white Antarctic wilderness. There's nothing but frozen horizon in every direction. The wind is soft but crisp, and beneath your feet lies something extraordinary. Under this icy continent is an entire network of rivers, lakes, and perhaps even oceans flowing and pulsing in complete darkness, sealed away for thousands, even millions of years. Imagine taking a soft breath and beginning to sink slowly, gently through the layers of compacted snow. The cold air wraps around you like a blanket, and the ice begins to glow faintly blue as the surface light fades above. You're not falling. You're drifting like a feather caught in a slow-motion snowstorm. Below, the ice thickens, compresses, and becomes crystal clear in places like ancient glass. Every meter you pass down tells a different story. Thousands of years ago, a snowflake landed, was buried, and became a chapter in a frozen book. Now you're slipping past those pages. You may be wondering, how deep does this go? And how could anything resembling an ocean possibly exist beneath such an enormous frozen weight? Ask yourself, can warmth exist beneath such cold? Can water flow where light never reaches? The ice sheet beneath you is not just a static block of frozen water. It's alive in its own glacial way. Beneath 3 or even 4 kilometers of solid ice, there are moving rivers, deep lakes, and even entire water systems. They are squeezed, warmed, and kept liquid by a quiet combination of pressure salt and Earth's deep geothermal hum. Somewhere far below you, Lake Vostok slumbers. It's the largest subglacial lake we've discovered, about the size of Lake Ontario. It's been sealed under ice for at least 15 million years. That means its waters haven't touched the atmosphere since woolly mammoths roamed the earth or before. You float downward, passing ancient air bubbles, trapped in the ice like thoughts sealed in crystal. Tiny time capsules. Some of them contain air from 800,000 years ago. You can almost hear them whisper. What was Earth like then? What were its skies filled with? Did it smell different? Now imagine the ice begins to thin, not because you're rising to the surface, but because you're approaching something different. It's darker here, denser, quieter somehow. And suddenly there it is, flat, cold water, like a mirror in the dark. You've reached one of Antarctica's hidden lakes. You hover above its surface, untouched and unmoved for eons. There's no wind here, no sunlight, just a vast, still presence, ancient and unknown. You might wonder if anything stirs below that surface. Could anything live here in the total dark, cut off from time? You breathe in, and the thought dissolves. There's no hurry to know just yet. These subglacial lakes are part of something even larger. A secret ocean scattered in pieces beneath kilometers of ice. They connect through narrow channels and pressurized tunnels. Some trickle, some surge. Some remain sealed off entirely, private and silent. It's hard to believe, but all this shadowy, pressurized, watery world exists not below some distant planet, but right here on Earth, as close as your next breath, just beneath the thick crust of the southernmost continent. And now, as you float quietly above that hidden water, a gentle hum begins to rise, not from the lake itself, but from the earth below it. Heat, pressure, life, maybe, or just the slow, patient shifting of stone and ice. It's peaceful here. It feels like time is asleep, and yet deep beneath you the planet is very gently breathing. Now that you've arrived in this buried world, let yourself linger a moment. The lake's surface doesn't ripple. It barely seems to move. And yet it's part of a land that has always been in motion. Antarctica wears its ice like a crown, vast, ancient, and impossibly heavy. Let's rise gently now, just a little into the heart of the ice sheet above. You're floating through a crystalline maze, compact, layered, and filled with whispers of snowstorms long forgotten. This crown of ice isn't just one solid slab. It's a layered history book that stretches back nearly 34 million years when the first major ice began to take hold. Back then, the Earth cooled just enough to allow snow to pile without melting. Slowly, like a patient painter brushing white across a blue canvas, Antarctica began to freeze over. That process never truly stopped. Even now, snow continues to fall at the center of the continent, just a few centimeters a year, but it adds up. Pressed down over millennia, it becomes part of the ice sheet one flake at a time. And now this icy crown is enormous. Some parts are nearly 5 kilometers thick. That's like stacking 15 Eiffel Towers, one on top of another. And the weight, it's almost beyond imagining. So heavy that it actually presses the Earth's crust down like a mattress beneath you. If you removed all that ice, the bedrock would spring upward again, slowly, like a sigh of relief. But even with all this crushing weight, something surprising happens beneath. Pressure. It turns out isn't just a burden, it's also a warm hug. The deeper you go, the more compressed the ice becomes, and the more heat seeps up from below. Earth's mantle far beneath the crust is always offering a little warmth to the rocks above it. That gentle heat nudges the bottom of the ice sheet, melting it ever so slightly, just enough to form tiny rivulets, slippery channels, even vast lakes. Imagine Antarctica's ice not as a frozen block, but as a slow-moving glacier, a thick, crawling river of ice. It's not frozen in place. It's flowing, inching outward toward the coasts, at glacial speed, literally. Some parts move a few meters a year, others as fast as a few hundred meters. Annually carried forward by the slippery layer of meltwater at their base. It's a strange thought, isn't it? That something so ancient and frozen is also quietly on the move. If you close your eyes and listen, you can almost hear it groan and creak and hum like a great sleeping beast shifting in its dreams. The ice sheet isn't just a passive cap, it's dynamic. It shapes everything beneath it. Its weight carves the land, fills valleys, buries mountains. But it also hides and protects. Beneath its blanket, ecosystems and water systems may have survived for millions of years without interruption. Now let your mind wander to what lies trapped in that deep time. Imagine a drop of water sealed in the base of the ice sheet when early humans first lit fire. Or when dinosaurs roamed warm forests that once stood where ice now rules. That drop, now part of a subglacial stream, might just be flowing again slowly toward a hidden lake. You might ask, how stable is all this? Could it collapse? Could the lakes drain or the rivers stop? And if they did, would we even know? The answer is both soothing and strange. The ice sheet is stable, but not immovable. It listens to the planet. It reacts. When temperatures shift or snowfall increases or geothermal heat rises just a bit more, the system responds. Water flows a little faster. Ice moves a little more freely. The whole frozen crown tilts, breathes, and adapts over centuries. Right now, scientists believe there are over 400 subglacial lakes beneath Antarctica. Some of them are small. Others, like Lake Vostok, span over 12,000 square kilometers, more than 4 times the size of Rhode Island. Most were discovered by accident using radar pulses sent through the ice. The sound echoes back differently when it hits liquid water, whispering a secret through miles of frozen silence. Some of those lakes are connected part of intricate systems of drainage and slow flow. Others are isolated, sealed off completely. But all of them exist beneath this frozen crown in a world of soft pressure and utter quiet. You might wonder, does the ice above ever notice what stirs below? Could a sudden shift in water create a ripple in the frozen ceiling above? It's not just possible, it's real. Some subglacial lakes occasionally drain or fill, causing the ice above to rise or fall by several centimeters. Imagine the land itself breathing, adjusting. And all of this is invisible from the surface. If you stood above Lake Vostok right now, all you'd see is snow, just white, endless snow. But underneath, a secret ocean pulses gently, patient and silent. There's something deeply calming about knowing the world is still so full of mystery, that below the coldest, driest, most remote continent on Earth, there's water warmth and ancient rhythm. Let yourself sink once again, gently passing through the pressed glass of ice. The world becomes quieter, still hushed by layers upon layers of frozen time. You are not alone down here, though it may feel like it. Beneath your drifting form, the earth has secrets to whisper, secrets warmed not by sunlight, but by the slow pulse of its molten heart. You might think of Antarctica as a place locked in perpetual frost, a continent that should, by all logic, be cold to its very core. And yet just beneath the base of its thickest ice lies a surprising truth: there is heat here. Not the kind that burns or glows, but a soft, ancient warmth rising steadily from below. This is geothermal energy, the gentle heat radiating from the Earth's mantle far beneath the crust. It doesn't roar, it doesn't erupt. It simply seeps upward, patient and consistent, like the slow exhale of a sleeping giant. Imagine the rocky floor beneath you warmed from within. That heat presses up against the overlying ice, never melting it entirely, but softening it, coaxing it into motion. Just enough to cause water to form at the ice's base, trapped between solid ice above and solid earth below. Some places under Antarctica are warmer than others. Around the West Antarctic Rift, for example, geothermal heat flux can reach over 150 milliwatts per square meter, like a tiny invisible campfire beneath the ice. It's not enough to boil water, but enough to keep it from freezing when it's under tremendous pressure. Geothermal heat varies depending on the geology below. In some areas, it's as if the bedrock is whispering softly to the ice, barely warming it. In others, it's more insistent, heating things just enough to create entire networks of liquid water. And once that water exists, it starts to move, helped by gravity salt and the sheer pressure of kilometers of ice bearing down. Now ask yourself, what does warmth mean in a place this cold? Could something as faint as the Earth's inner breath be enough to give rise to an entire ecosystem? Could it mean life, fragile, hidden, flickering in the dark? Scientists have discovered that in some regions beneath the ice, geothermal heat may be concentrated by volcanic activity. Not fire and lava, exactly just warmer rock, sometimes part of a volcanic chain that never reaches the surface. One such area lies under Marie Birdland, where hidden heat rises like an unseen lantern, softening the base of the ice sheet. What's remarkable is how silently this warmth works. There's no light show, no drama. Just ice melting from the bottom up a few millimeters at a time, creating vast pockets of water that never see the sky. Take Lake Whillans, for example. Located beneath 800 meters of ice, it's part of a dynamic system that researchers drilled into carefully in 2013. What they found was liquid water, and more astonishingly, microbial life. Life that thrives without sunlight, relying on chemicals from rock and sediment for energy. That discovery changed the way we see Antarctica's subsurface. No longer just a place of frozen stillness, but one where warmth fosters life in the most unexpected corners. The idea that the planet itself, its molten core, its restless tectonics, could quietly nurture ecosystems deep under the ice is something you might want to hold on to as you drift. Now imagine the contrast, a continent that feels like death on the surface. No trees, no rivers, barely even sound. And yet beneath it, warmth seeps upward and water flows. The ice sheet is like a weighted blanket, and under it the earth is quietly alive. Picture a soft glow imaginary, of course, rising from the rocks below. It doesn't push, it doesn't boil, it just persists. Over centuries and millennia, this geothermal warmth reshapes the landscape beneath the ice, melting it just enough to make room for hidden rivers and lakes. The entire underworld becomes a dark, fluid tapestry. Let yourself drift through that thought. That warmth exists even in the coldest places, that it doesn't need to be strong to be constant, that even here at the far end of the Earth's core still whispers stories to its surface, slowly, sleepily, but unceasing. You might wonder now, how do we know how warm it is under all that ice? After all, we can't just peel it back and take a measurement. The answer lies in math, sound, and satellites. Scientists use radar to map where the ice glides more easily, where meltwater flows, and where pockets of warmth soften the cold from below. These tools listen to the shape of the land without ever seeing it. Some models suggest that geothermal heat might even help regulate the motion of the ice sheet itself. Where the warmth is greater, ice flows more freely, like syrup sliding down a plate. Where the heat is low, ice stiffens, resisting movement. In this way, the Earth's inner fire acts like a hidden hand, guiding the shape and pace of Antarctica's glacial drift. So as you rest, consider the patience of warmth, its quiet influence, its ability to create, sustain, and gently shift the frozen world above it. In a place where light cannot go, heat becomes the silent architect of change. Drift lower now as if gravity itself has gone gentle. The ice above you grows thinner, softer, and you begin to sense something beneath, not solid, not rock, but movement. A flow. It doesn't rush or roar. It creeps, it slides, it murmurs along hidden channels carved by time and pressure. You've reached a place where rivers run in utter darkness. Subglacial rivers are unlike any others on Earth. They don't sparkle in the sun. They don't roar over rocks or reflect the sky. Instead, they glide beneath kilometers of ice, moving through narrow pressurized passages carved into the base of the ice sheet or sculpted through the sediment below. It's here in this buried hydrological maze that Antarctica begins to breathe. These rivers aren't wide, many are only meters across, but they form delicate branching systems like veins under translucent skin. They are part of a hidden pulse, feeding the lakes, draining the melt, redistributing warmth in a world otherwise frozen solid. Some of these rivers stretch hundreds of kilometers. One such network connects Lake Vostok to smaller neighboring lakes, suggesting a vast subsurface watershed. It's possible some scientists even suspect that Lake Vostok has been slowly flowing for millions of years, connected to a buried network that reaches across the continent. But these rivers don't flow because of rain or surface melt. There's no sunlight to drive evaporation, no clouds to drop snow that becomes runoff. Instead, they are born from the ice itself, from its slow melt, its pressure-induced transformation, and the gentle encouragement of geothermal heat below. And the pressure, oh, the pressure. Imagine standing under 3,000 meters of ice. The weight above would press on you with over 300 times the atmospheric pressure at sea level. But for the rivers, that pressure is a gift. It keeps the water liquid moving, humming softly under the crushing silence. You might wonder, can rivers even exist without gravity driving them in the way we know? Is flow still flow if there's no sunlight to glint off its surface? Think of it like this. These rivers are slow thinkers. They take their time. They wander, not rush. But still they move toward the coast, toward lower elevations, or toward some deep, patient lake that waits in silence to be filled. Some rivers drain, some swell, some do both in cycles we're just beginning to understand. A subglacial flood, when it happens, can be a quiet but powerful thing. One such event occurred beneath the East Antarctic ice sheet, an enormous pulse of water that drained from one hidden lake to another over the course of a year, altering the height of the ice surface by meters. Imagine the ice above you suddenly lifting just slightly, like the lid of a pot bubbling from beneath. No cracks, no sound, just the Earth's quiet breath moving through liquid veins. You float now alongside one of these rivers. It's narrow, maybe a few meters wide, its walls made of ice and compressed sediment. The water here isn't clear, it's murky, rich with minerals and fine glacial flour. Bits of ground-up rock swirl in suspension, telling stories of mountains crushed by time. This river doesn't care about day or night. It doesn't remember seasons. But it remembers weight, it remembers warmth, and it remembers the landscape it helped shape over millennia. Ask yourself, what would it feel like to touch this water? Would it be freezing cold or strangely warm, softened by pressure and the Earth's sighing heat? Would you feel its movement like a whisper, a nudge, a pulse? You may never touch it, but you're not far from knowing it. Scientists use radar and gravity measurements to trace the course of these rivers. The European Space Agency's Cryosat mission, for instance, has helped reveal how ice thins and thickens as rivers surge and pause beneath. The more we study them, the more we realize how crucial these hidden rivers are, not just to Antarctica, but to the planet. They control how ice flows above, how fast glaciers move, and even how the continent's ice might respond to a warming climate. Some researchers believe that beneath the West Antarctic ice sheet, there may be a vast river system hundreds of kilometers long, draining from deep within the interior to the Amundsen Sea. If true, it would be one of the most secretive rivers on Earth. Let yourself feel that motion now. Not fast, not loud, but sure. A whisper beneath miles of ice, a stream that may have never felt the touch of wind or sun, but still carves and carries and connects. It's a peaceful thought, isn't it? That even in utter darkness, water still finds a way. That pressure becomes passage. That flow can exist without a splash. And just maybe, that there are still rivers left to discover on this planet, rivers no human has seen, but which have flowed beneath our feet for longer than we've been here. You follow the soft current, now gliding along with the quiet rhythm of the river, until it widens slowly, subtly like a breath, expanding in a dream. Ahead of you stretches something vast and still. Not a stream, not a tunnel, but a lake. Hidden, ancient, and perfect in its silence. Welcome to the world of subglacial lakes. Giant pockets of water that rest beneath Antarctica's ice sheet, completely sealed off from the sky. These are not the kinds of lakes you know. There is no wind to ripple their surface, no sunlight to shimmer across them. They exist in total darkness, beneath up to 4 kilometers of ice, in a place that has not seen daylight in millions of years. The most famous of these is Lake Vostok, an inland sea beneath the East Antarctic ice sheet. It's enormous, stretching nearly 250 kilometers long and 50 kilometers wide, with an average depth of 432 meters. That's over 5,400 cubic kilometers of water quietly waiting beneath 3.7 kilometers of ice. For comparison, that's about the size of Lake Michigan. You might wonder, how has it stayed liquid? The answer again is pressure and geothermal heat. Like a hand gently pressing on a snow globe, the immense weight of the overlying ice lowers the freezing point of water. Combine that with heat rising from the Earth's interior, and a hidden lake is born. But Vostok is not alone. Scientists have now discovered over 400 subglacial lakes beneath Antarctica, some large and deep, others small and scattered. Many are believed to have existed in isolation for hundreds of thousands, even millions of years. These lakes don't exchange water with the surface. They don't evaporate. They simply persist, protected by time and pressure. Let yourself imagine floating above one of them, your body weightless and calm. You're suspended between two worlds, ice above, rock below. And between them, this pocket of liquid serenity, holding secrets older than our species. Could anything be alive in these lakes? That question has long fascinated scientists. Life in total darkness, cut off from the air, untouched by sunlight. It seems impossible, yet we know that on Earth life always finds a way. In 2013, when researchers carefully drilled into Lake Whillans, they recovered water samples that changed everything. They found microbes, tiny living organisms, thriving in the cold, dark water. These microbes weren't photosynthetic. Instead, they fed on chemical reactions involving sulfur and iron, drawing energy from the rock and sediment below. What does that mean? It means that life beneath the ice doesn't need the sun. It means that ancient lakes like Vostok might harbor their own microbial communities, living fossils perhaps still active, still evolving, still listening to the whispers of the earth. You might ask yourself now, what would it look like if we could shine a light into one of these lakes? Would the water be clear or cloudy? Would it shimmer with tiny life? Would there be movement slow and steady like breath? Or would it all be still, resting in its own ancient hush? The truth is, we don't fully know yet. Lake Vostok remains mostly untouched. Though a Russian drilling team reached its surface in 2012, their method didn't allow for direct, clean sampling of the water. More cautious, sterile missions are being planned, because this isn't just a matter of exploration. It's also a matter of protection. These lakes may hold clues to Earth's past climate. Trapped within their sediments could be records of ancient ecosystems, shifts in temperature, and perhaps even long-lost DNA. They are time capsules, untouched, preserved by ice and pressure. To disturb them carelessly would be to tear a page from a book that has waited eons to be read. Still, the idea is irresistible. A sealed lake buried for millions of years, completely cut off from the outside world. A quiet world, unknowable and unexplored. It stirs the imagination, and not just of those who study Earth. Astrobiologists, too, are fascinated by these lakes. They see in them a model for life beyond our planet. Could the ice-covered oceans of Europa, one of Jupiter's moons, or Enceladus, a moon of Saturn harbor similar subsurface lakes and seas? Could microbes there survive as they do here, fed not by sunlight, but by chemistry and heat? It's a dreamy thought, isn't it? That beneath layers of ice, both on our world and on distant moons, entire ecosystems might be humming softly in the dark, untouched, undisturbed, and full of life. Now imagine that you are still floating above Lake Vostok. The ice above glows faintly like blue velvet. The water below stretches into a vastness you can't quite measure. Nothing moves, nothing blinks. But you feel somehow that you are not entirely alone. There's peace in that stillness. There's awe in that quiet. And there's wonder in knowing that even now, beneath all this cold and weight, there are stories still being written softly, silently, drop by drop. You hover now over that vast, still lake, Your presence barely a whisper. The silence is complete, but in the mind's eye there's motion. Invisible currents stir ever so slightly, a kind of breath beneath the ice. The longer you float here, the more you begin to wonder what else might be down here. Besides water, could something live in this dark, sealed world? Life, as you know it, thrives on energy, sunlight, warmth, nutrients, none of which seem present in this ice-covered realm. And yet, the deeper we look into these subglacial lakes, the more evidence we find that life doesn't always follow our expectations. It's almost poetic, isn't it? That life can flicker in places where everything screams lifeless. Total darkness, crushing pressure, near freezing temperatures. It's like the planet's own bedtime story, quiet, strange, and softly astonishing. Scientists have discovered microbes living beneath Antarctica's ice in more than one location now. Lake Whillans, which lies under 800 meters of ice, offered the first clear evidence of subglacial life. When researchers melted a narrow tunnel down and collected samples in 2013, they found over 4,000 different microbial species alive and well in water that hadn't seen sunlight for hundreds of thousands of years. These tiny creatures feed not on sugars or sunlight, but on minerals. They use chemosynthesis, a process that lets them extract energy from inorganic substances like sulfur and iron, often leached from bedrock below. This is the same strategy used by life forms found in the deep oceans near hydrothermal vents. Now ask yourself, if such life can thrive here, in the dark heart of a glacier, what does that say about the resilience of life itself? Could there be whole ecosystems beneath the Antarctic ice, quietly doing their own thing, following their own rules? Even stranger is the idea that some of these life forms might be entirely unique. If Lake Vostok has been sealed off for millions of years, it's possible the microbes, or perhaps something more complex, have evolved along a completely separate path. Imagine organisms that don't know sunlight, that have never needed to swim toward the surface. Their eyes might be useless, their senses tuned to vibrations, chemistry, or temperature. It makes you wonder, what does evolution do in a place like this? Does it slow down, curling inward like a fern, or does it get creative in the dark? In 2021, researchers studying sediments from beneath the Thwaites Glacier on the opposite side of the continent found evidence of ancient life forms preserved in ice. Their DNA hinted at cyanobacteria diatoms and even small multicellular organisms. Not current inhabitants, perhaps, but echoes of life that once flowed in meltwater, frozen into the depths. And more recently, beneath the Filchner-Rana ice shelf, a British Antarctic survey team accidentally discovered stationary organisms clinging to a boulder half a kilometer below the ice. No one expected to find anything living there, let alone something fixed in place, like a sea sponge surviving in such complete isolation. That discovery raised an astonishing question. What are they feeding on? The ocean current is slow there. No sunlight, no fresh sediment, no obvious nutrient source. Yet there they sit, as if waiting, as if simply being is enough. So now picture the possibility that somewhere deep beneath the Antarctic ice, tucked away in a hidden lake, or curling through a subglacial stream, there might be creatures that haven't seen daylight in tens of millions of years. Maybe they glow faintly. Maybe they pulse with movement. Maybe they are no larger than a fingernail. Or maybe some are stranger still. Would you recognize them as life? Could you look through the murky waters of Lake Vostok and know what you were seeing? And what would it mean to find something alive that has never breathed our air, never known a season, never felt the tides? These are the kinds of questions that keep scientists curious and keep dreamers wide-eyed. Because if life can exist here in the dark, under pressure with no sun, no surface contact, then it can exist in so many other places, on other icy moons like Europa and Enceladus, or even in the distant crust of Mars. You drift again, letting that thought settle. That life might be not the exception, but the rule. That it might sprout in shadows, curl into cracks, hum silently beneath layers of forgotten time. And beneath Antarctica's ice sheet, life does something else too. It shapes the world around it. Microbes help break down minerals. Their metabolic processes alter chemistry. Over centuries, they may subtly change the very structure of lake sediments and influence how water moves and flows. They are not just passengers. They are architects. Even without light, even without warmth, these tiny beings become part of the continent's quiet machinery. So rest here a while longer, floating above the unseen. Let your thoughts curl around the idea that we are still beginners when it comes to understanding this planet. That we still find life where we expect silence. That beneath the coldest place on Earth, something might be quietly thriving and patiently waiting. Let your breath slow as you float higher again, up through the still water into the ancient ice above. The pressure fades slightly, and in the distance, just beyond the ice, crystal haze, you begin to notice something suspended, trapped inside the frozen walls. Tiny spheres, like pearls. But these are not made of calcium or sand. They are bubbles, little spheres of air, frozen in place for thousands or even hundreds of thousands of years. Each one is a whisper, a breath from another world. Welcome to the breath of an ancient ocean. These air bubbles are perhaps the most delicate time capsules ever discovered. Locked deep in the ice sheet, they were formed as layer after layer of snow fell compacted and turned into glacial ice. As each new snowfall pressed downward, the air between snowflakes was squeezed into tiny pockets and frozen there. Imagine snowflakes falling 800,000 years ago. A mammoth lumbers across a grassy steppe. No cities, no machines, no clocks, just wind ice and the slow, pulsing breath of the earth. That same snow melted, refroze and compressed, has held its breath ever since. When scientists drill deep ice cores, sometimes up to 3.2 kilometers deep, they extract these frozen bubbles. Each one can be analyzed to reveal the exact composition of Earth's atmosphere at the time it formed. Oxygen, carbon dioxide, methane, even traces of volcanic ash or distant pollen. Through these bubbles, we learn not only about temperature shifts and climate cycles, but also about Earth's most intimate moods, its storms, its fires, its slow exhalations of CO2 from the ocean or the soil. You might ask, how can a single bubble tell us all this? How can something so small speak so loudly? The answer is gently. Through isotopes, through ratios of oxygen-18 and oxygen-16, which shift depending on global temperatures. Through the balance of gases that hint at greenhouse warmth or icy slumber. Each bubble, when melted and studied, becomes a tiny oracle, offering glimpses into epochs before history. And here's the part that settles softly into your thoughts. We don't just use these bubbles to study the past, we use them to understand the future. By comparing ancient air bubbles to modern atmospheric measurements, scientists have seen how fast carbon dioxide levels have risen in just the last century. During most of the last 800,000 years, CO2 rarely climbed above 280 parts per million, but today it exceeds 420 ppm. The bubbles don't judge. They just show us the contrast, calmly, silently. Now let your imagination drift to what else might be frozen in the ice. Pollen from extinct plants, soot from ancient wildfires, dust blown from deserts long forgotten. Even microbes frozen but still viable, waiting for warmth like seeds under winter soil. The ice sheet becomes a diary, each layer a page. And the further down you go, the older the writing becomes. It's not the hurried scribble of a novelist. It's the measured, elegant record of a planet at rest. And there's something beautiful, even comforting, in knowing that Earth keeps its own memories, that the planet doesn't forget, even when we do. Take Lake Vostok again. Scientists believe the sediments at its bottom might contain records of Earth's climate from millions of years ago. Not just the atmosphere, but the temperature of the lake itself, the chemistry of the water, even traces of the living world that may once have existed around it, before ice swallowed it whole. In that way, the lakes and rivers under Antarctica aren't just places, they're repositories. They hold not just water, but memory. They are Earth's quiet archives preserving the breath of each passing age. Now think for a moment, what does your breath mean? It's invisible, fleeting. You exhale, and it's gone. But here, beneath kilometers of silence, breaths are held for 1,000 lifetimes, trapped, preserved, waiting. It's a soft paradox. In a place so harsh and cold, the most delicate things, airtime, warmth, are the ones that survive best. And so you might wonder, what secrets are we still waiting to uncover? What stories lie in bubbles, not yet drilled in lakes, not yet sampled? Will we find ancient viruses, dormant seeds, a molecule that changes how we understand life? Or perhaps the greater discovery is this, that the Earth remembers, that even under the weight of ice and time, the smallest traces are held like lullabies in a snow globe. So you float here, surrounded by the breath of ancient oceans. The ice walls are lined with invisible songs, each one waiting to be heard. And for now, you don't need to decipher them. Just rest. Let them wash over you like echoes from another time. They've waited this long. They'll wait a little longer. You drift now deeper still to a place where water and rock begin to meet. The ice above you thickens once more, compressing into ancient glass. But beneath you, something changes. The smooth floor gives way to something rougher, darker sediment. Rock, the very bones of the continent. This is Antarctica's hidden bedrock, the forgotten foundation upon which the ice sheet rests. And beneath all the glittering stillness above it is anything but simple. If you could reach your hand into this shadowed terrain, you'd feel not just one kind of rock or soil, but a patchwork fractured buried mountains, sunken basins, twisted layers of sediment, and volcanic stone. The surface of this land, though unseen, is more dramatic than you might imagine. It's not flat, not smooth. In many places, it's deeply scarred. Beneath the East Antarctic ice sheet, for instance, lies a range of buried mountains called the Gamburtsev subglacial mountains. These jagged peaks stretch over 200 kilometers, roughly the length of the Alps, with some estimated to rise 3,000 meters from their base. And yet, no one has ever seen them with their own eyes. They are completely entombed beneath over 4 kilometers of ice. Just imagine that, an entire mountain range lost beneath a continent of snow. Frozen, forgotten, and yet still there, sharp and silent, like a secret waiting to be remembered. These mountains are more than just scenery. They may have helped Antarctica become the frozen land it is today. Scientists believe that they served as the original gathering point for ice, encouraging snowfall to accumulate and remain trapped. In essence, they helped kickstart the formation of the very ice sheet that now buries them. Elsewhere across the continent, the bedrock tells different stories. Deep trenches and rifts suggest that parts of Antarctica are still slowly pulling apart. In West Antarctica, the crust is thinner, geologically younger, and more active. Volcanic heat bubbles upward here, especially in the West Antarctic rift system, making the ice above more dynamic, more mobile, and more vulnerable to change. As you drift along this buried landscape, try to picture it. A sunken plain beneath the Thwaites Glacier, often called the Doomsday Glacier. slopes downward toward the sea, making it easier for warm ocean water to creep in under the ice. This gentle tilt allows glaciers to retreat quickly once they've begun to melt like marbles rolling down a slow ramp. Ask yourself, what kind of continent exists beneath all this ice? Would it look like any other? Or has it become something entirely new, shaped not by sunlight and erosion, but by the slow grind of glaciers? Beneath some of the thickest ice lies ancient sediment, mud, and silt deposited millions of years ago when Antarctica was warm and lush, covered with forests and flowing rivers. Core samples taken from the seabed off the coast suggest that Antarctica once teemed with life. Fossilized pollen leaves, even traces of temperate rainforest, have been found dating back 90 million years. Back then, Earth's climate was warmer. Antarctica wasn't frozen, it was green. Dinosaurs walked along its riverbanks, giant ferns unfurled in the midnight summer sun. The land beneath the ice remembers that. It holds on to the shape of old rivers, the texture of vanished soils, the quiet memory of rain. And now that same ground plays a crucial role in how Antarctica behaves today. Soft sediments allow glaciers to move more quickly. Harder bedrock holds them in place. Where there are steep inclines, ice flows fast. Where there are shallow slopes or rocky ridges, the ice can snag and resist. It's like watching a giant slow dance between the land and the ice above it. One shaping the other, millimeter by millimeter over millions of years. Geologists study these hidden terrains using radar and seismic waves, sending sound down through the ice and listening carefully to the echoes. Each bounce, each delay, reveals something new. A hill, a valley, a rift, a forgotten coastline. Some regions even contain ancient cratons, old stable pieces of Earth's crust that have survived for billions of years. Others lie over volcanic hotspots. One such feature, Mount Erebus, is the southernmost active volcano on Earth, its lava lake quietly bubbling beneath a dome of ice. Yes, even fire lives here. It's strange, isn't it? That beneath the coldest, driest place on the planet, there's a world shaped by heat and movement. A land that sleeps but doesn't stop. And so, as you glide through this buried landscape, let your thoughts settle on the idea of memory. That rock too can remember. That land can wait. That even without eyes or ears or words, the earth tells stories through its shape. These are stories of mountains built and buried, rivers that once flowed under open sky, forests that turned to fossils beneath falling snow. And now all of it lies beneath your drifting body, a world not lost, but simply paused. Let yourself rise slightly now, just enough to feel the ice breathe again around you. You're still beneath Antarctica's vast sheet, but here something begins to shift. The world above is not as thick, not as still. The bottom of the ice sheet, once pinned tightly to solid rock, is loosening. You are approaching the edge where the frozen continent meets the restless sea. This is the world of ice shelves. Floating fragile and vast, these are the great ledges of Antarctica's glacial crown. Slabs of ice that extend from the land into the ocean, still attached to the continent, but no longer resting on rock. Ice shelves form where glaciers and ice streams flow outward and reach the coast, spreading across the ocean's surface like frozen wings. Some are enormous. The Ross Ice Shelf, for example, is roughly the size of France, stretching over 500,000 square kilometers. Others, like the Larsen Ice Shelf on the Antarctic Peninsula, are smaller, more fractured, but no less important. You float now beneath one of these shelves. Above you is a ceiling of ancient ice, rippling gently under the weight of wind and snow. Below, the ocean is dark and still. Salt water meets fresh water. Warmth meets cold. and somewhere in between, balance. Ask yourself, how does this delicate floating world stay together? How can something so heavy, hundreds of meters thick, float? The answer lies in the density of water and the nature of ice itself. Ice is less dense than seawater, so it floats. But only a small fraction shows above the surface. Like an iceberg, an ice shelf reveals just a tenth of its mass to the open air. The rest lurks beneath, submerged and unseen. And here's where things become quietly dramatic. The base of the ice shelf, in constant contact with ocean water, is melting. Not all at once, not violently, but steadily, softly. A few millimeters, then centimeters, then more. The culprit, circumpolar deep water. A layer of relatively warm, salty water that circles Antarctica like an invisible belt. When this water rises and slips beneath ice shelves, it begins to erode them from below. This undercutting doesn't just thin the shelves, it destabilizes them. And when ice shelves weaken, the glaciers that feed them begin to flow faster. Think of ice shelves as the gatekeepers. They hold the glaciers in place, like a hand pressing lightly on the end of a tube of toothpaste. Remove the hand, and the flow begins to surge. Ice that once took centuries to reach the sea may arrive in decades. That's why the collapse of Larsen B ice shelf in 2002 was so startling. In just over a month, an area of ice the size of Rhode Island disintegrated into the ocean. The event was too fast for comfort and marked a turning point in how we understand ice shelf vulnerability. Now scientists keep careful watch on shelves like Thwaites and Pine Island, where warm water continues its slow work beneath. In some regions, the melt rate has been recorded at 50 meters per year, a quiet but relentless erosion of the frozen edge. You drift beneath an ice shelf now where life has learned to exist in near-constant shadow. Strange creatures hang from the ice's underside, ice fish, glass sponges, tiny amphipods that feed on detritus drifting down from above. Here, even darkness has an ecosystem. A British expedition in 2021 found organisms attached to a boulder beneath 900 meters of ice, clinging to life in a place thought to be utterly barren. No sunlight, no obvious food source. Yet there they were, still pale and quietly surviving. What sustains life in such a place? It might be particles from melting glaciers, or chemicals released from the seafloor, or perhaps currents that bring in just enough nutrients to keep the cycle turning. You might ask yourself now, how long has this balance lasted, and what happens if it changes? If the ice shelves melt too quickly, the glaciers behind them will accelerate. More ice enters the ocean, sea levels rise, but it's not just about numbers and meters. It's about rhythm, disruption, a system that has operated in near equilibrium for thousands of years, beginning to wobble. Still, for now, in this moment, beneath this shelf, the world remains peaceful. You are surrounded by a cathedral of cold pillars of ice that reach deep into the sea, casting long shadows in the gloom. And beneath them, currents swirl softly, brushing against the undersides of floating giants. It's a place of waiting, of tension held in perfect suspension, a continent leaning out over the edge of the ocean, exhaling slowly through its melting shelves. Let your mind rest here. Let the quiet lull you. Even as the ice melts, even as the future shifts, this moment, this hidden stillness remains untouched. You glide farther along the underbelly of Antarctica, letting the lightless sea rock you softly. Above, the ice shelf continues its quiet drift into open water, slowly calving off at its front. Now you begin to pass the boundary between what floats and what falls. The place where ancient ice finally breaks free. The moment the glacier becomes an iceberg. It's a gentle kind of birth, at least from down here. No fanfare, no flash. Just a long, slow crack forming over months or even years until the final sigh releases a monolith into the sea. And just like that, a new iceberg drifts into the world. Imagine the scene above a towering block of ice, hundreds of meters tall, sheared from the glacier edge. To the watching satellites, it looks like a white puzzle piece separating from the continent. Some of these pieces are the size of cities. One of the largest in recorded history, iceberg A76, measured around 4,300 square kilometers, larger than Luxembourg. That's a floating city of silence. You drift beneath it now, the hull of this fresh iceberg, vast and jagged. Underneath, it's not smooth, not elegant. It's pitted and scalloped like the belly of a sleeping whale. Water sloshes gently around the base, carving it over time into curves and flutes. But here's the thing about icebergs: they are wanderers. Once released, they are no longer rooted. They become drifters carried by ocean currents and winds, sometimes for years. Some will loop around Antarctica. Some will escape into the Southern Ocean. A few will travel north, melting slowly as they go, fading into the sea like whispered thoughts. Ask yourself now, what story does an iceberg carry? What memories does it hold? Each iceberg is a slice of time. Its layers tell the tale of snowfall from long before you were born. The deeper the ice, the older the snow. The more compressed the layers, the more intense the story. Some icebergs calved today may carry ice more than 10,000 years old. In that way, icebergs are not just travelers, they're messengers. They bring ancient polar history to new waters, like floating letters from the past. And while many icebergs are destined to fade into warmer seas, some meet a more sudden end. A wave, a shift in weight, a sudden crack, and the iceberg rolls. Few sights on Earth are more dramatic than an iceberg flipping. What was once hidden below becomes the surface. Jagged spires of deep blue ice rise into the air, dripping and groaning. Sometimes, if the flip is large enough, it triggers waves and sends sea spray high into the sky. Down here below, you would feel it not as sound, but as vibration. A long, slow thud echoing through the water, like thunder rolling through your bones. Yet not all icebergs are born of drama. Many break away, quietly dissolving over time into iceberg graveyards, regions of calm, where currents collect these giants and let them melt in peace. One such place lies near South Georgia Island, where cold Antarctic water meets warmer northern seas. There, old icebergs lie adrift, trailing meltwater like faint breath in winter air. And meltwater isn't just passive. When an iceberg melts, especially a large one, it releases billions of tons of fresh water into the ocean. That fresh water can change local salinity, affect circulation, even fertilize marine ecosystems with trapped nutrients. It's like dropping a giant mineral tablet into the sea. In fact, studies show that large icebergs can boost local plankton blooms, tiny plant-like organisms that form the base of the ocean food web. Where they bloom, fish follow. Whales follow the fish. Life blooms in the wake of something that seems, at first glance, lifeless. So while icebergs may seem like drifting monuments to melting, they're also bringers of change, of nourishment, of gentle disruption. Even the color of an iceberg tells a tale. Most are white or blue colors, shaped by how light scatters through compressed ice. But occasionally you'll see green or even striped icebergs. These rare gems form when seawater or sediments get trapped and freeze in bands, creating what looks like abstract art floating through the fog. And what do you feel now drifting beside one of these travelers? You feel its age, perhaps, its softness, its silence, a reminder that even the coldest things move, that even the heaviest memories float. And so you continue your journey watching as the icebergs drift away, born of stillness, moved by currents destined to vanish. Let your mind drift with them for a moment. Let the edges blur. Let time dissolve like fresh water into salt. There is peace in knowing that even endings melting, drifting, fading can carry beauty. Now the ice is far behind you. You've followed the drifting giants into open sea, no longer bound by shelves or ledges, no longer shaded by the great ceiling of Antarctica's ice. The water is deeper here, darker, but alive in its own quiet way. You are entering the realm of the Southern Ocean, a hidden force in the planet's breathing, an unsung engine beneath the winds. This ocean encircles the entire continent like a cold flowing ring. It connects the waters of the Atlantic, Pacific, and Indian Oceans. It is in many ways Earth's great mixer, churning currents that help regulate temperature and distribute heat across the globe. And at the heart of it all is something steady, something vital, the Antarctic Circumpolar Current. This current is the strongest in the world, transporting more than 130 million cubic meters of water per second, about 100 times the flow of all Earth's rivers combined. It wraps around Antarctica like a belt uninterrupted by any continent, forming a fluid barrier that insulates the frozen land and shapes climate far beyond. You drift alongside this massive, invisible river now. You don't feel speed, but you sense direction, purpose. The current moves eastward, endless and reliable, a slow heartbeat in the body of the planet. But not all of this ocean is in motion. In certain places, something else begins to happen. Near the Antarctic coast, especially during winter, the surface water begins to freeze, not just into solid sea ice, but into something far stranger, brine rejection. As seawater freezes, it pushes salt out. That salty water sinks, becoming heavier, denser. This begins the creation of Antarctic bottom water, some of the coldest, most oxygen-rich water on Earth. It sinks and spreads across the ocean floor, flowing northward silently into the basins of other oceans. You might ask, why does that matter? Because this water, cold and slow, helps drive thermohaline circulation, a global conveyor belt of deep ocean currents that move nutrients, regulate temperatures, and shape the long-term rhythms of climate. A slow swirl that touches nearly every ocean on Earth. Pause for a moment and picture it. The sea around Antarctica, freezing at the surface, becoming saltier below, then sinking, creeping, flowing along the seafloor. A kind of ancient breath inhaled in the south, exhaled thousands of miles away. It's not just a system, it's a memory. Each pulse of water carries oxygen and carbon, heat and nutrients, history and hope. It's the ocean's own slow whisper, looping around the world. But the Southern Ocean is not always calm. Here the winds blow fierce and constant. The roaring 40s, furious, 50s and screaming 60s, bands of latitude known for their relentless gales, whip the surface into waves that can rise 10 meters high or more. The ocean churns, crashes, spins. And yet even in this stormy place, there is still peace beneath. You are deep now, past the reach of storms, floating in the belly of something vast. Around you, plankton drift in slow clouds. Small silver fish dart like thoughts. A whale passes in the distance, silent, enormous, timeless. This ocean is also a womb. Every year, krill, tiny shrimp-like creatures gather in swarms so large they can be seen from space. These swarms become food for penguins, seals, whales, and birds. Krill feed on phytoplankton, which bloom beneath the thinning sea ice during the Antarctic spring. This bloom in turn is fueled by nutrients, stirred by currents, and enriched by the melting edges of icebergs. It's all connected. Ice to ocean, ocean to life, life to air. Even you, breathing quietly now, are touched by this. About every second breath you take comes from oxygen produced in the ocean. Much of it thanks to the plankton that feed on Antarctic light and Antarctic melt. Ask yourself, how can a place so remote, so cold, so harsh, be so crucial to your own lungs? And what happens if this balance tips? With warming temperatures, sea ice forms later and melts sooner. Less ice means less brine rejection. Less brine rejection means slower sinking. That could stall the global conveyor belt. Nutrients may stop moving, waters may become stale, climate patterns may shift. Already, the Southern Ocean absorbs more than 40% of the carbon dioxide humans emit. It is a sponge quietly buffering our mistakes, but sponges become saturated and oceans grow weary. Still, for now, the current flows. The whales feed, the krill swarm, the sea breathes. And you float quietly through it all, just a passenger in the deepest rhythm on Earth. You're drifting now along the outer reaches of Antarctica's watery world, past the boundaries of ice shelves and iceberg graveyards through the Southern Ocean's eternal churn. But as you continue your quiet journey, the seafloor begins to rise gently beneath you, revealing something unexpected: hidden ridges, fossil-lined cliffs, and canyons carved not by water, but by time itself. You've reached the submerged past, the once green shores of a lost Antarctica. It's easy to forget that this continent wasn't always a frozen vault. But 100 million years ago, in the Cretaceous period, Antarctica was a lush and vibrant world. Picture it now not in ice and silence, but in soft green conifer trees swaying under a warm sun, rivers twisting through ferns, dinosaurs leaving footprints in mud that would later freeze into stone. Yes, Antarctica was once tropical. Positioned farther north, it sat closer to the equator, and the climate was warm and wet. Fossils from this era have been discovered high in the transantarctic mountains and even beneath the ice sheet, uncovered through core samples pulled from the seabed. In 2017, scientists drilled into the seafloor near the Amundsen Sea and pulled up sediment containing fossilized roots pollen and even fragments of ancient rainforest. The soil dated back 90 million years, when the region had a temperature around 12 to 54 Th, a far cry from today's sub-zero realm. Close your eyes and let that world unfold: ginkgo trees, flowering plants, buzzing insects, and riverbanks dotted with moss. Somewhere a feathered dinosaur chirps beneath a canopy of green. It feels like a dream, but it's a dream told in stone. The fossil record whispers these forgotten stories. In East Antarctica, scientists have found Glossopteris leaves a now extinct fern-like plant that once grew across the ancient supercontinent Gondwana. This shared vegetation ties Antarctica to Africa, South America, India, and Australia, proving that all were once united as one massive land. Drift deeper into this idea. Antarctica, the loneliest continent today, was once connected. Once part of something bigger. It was not always a place of isolation. It was a corridor of life. But then, over tens of millions of years, the plates shifted. Gondwana broke apart. Antarctica slowly drifted south inch by inch, like a wandering thought in the back of Earth's mind. As it moved, the climate cooled. Ice began to form. Forests receded. Rivers froze. Life ebbed away. By 34 million years ago, Antarctica was cold enough to develop its first permanent ice sheets. Over time, the ice thickened, spread, and took hold. And now you float above what was once a river delta, now buried beneath kilometers of ice and sea. Ask yourself, how long does it take for a forest to become a fossil? For warmth to become silence? Let your imagination run across the ancient land, past tree stumps. Now petrified through sediment, that once held frogs and beetles across valleys that haven't seen sunlight in 30 million years. And in some places, perhaps those forests never fully died. In deep lake beds, in patches of sediment sealed off by time and pressure, microbial life may still carry echoes of that green past. Tiny survivors of ancient ecosystems still metabolizing in the dark. You might wonder, will this past return? In a warming world, there's a strange irony. As glaciers retreat, they may expose these fossil beds once again. The edge of the continent may over time reveal tree roots trapped in permafrost or bones curled beneath layers of silt. But the return would not be gentle. It would be a rewind played too quickly, an unfreezing that comes not from nature's rhythm, but from imbalance. Still, for now, this ancient continent rests. The rivers are locked beneath ice, the trees are stone, the dinosaurs are dreams. But their stories remain fossilized in cliffs, embedded in seabeds, hidden in the subtle curve of a forgotten ridge. And you, floating quietly through this submerged past, are not disturbing anything. You're just listening, listening to a land that once bloomed, to a forest that once breathed, to a time when this place, now ruled by ice, shimmered with leaves and sunlight. A quiet reminder, nothing is ever only what it is now. Even the coldest continent remembers warmth. The sea around you grows darker, now quieter, more reflective, as if it knows you've passed through something sacred. Behind you lies the memory of green forests and feathered giants. Ahead, something stranger still. Not ancient warmth, but modern mystery. A region not fossilized in stone, but alive in slow motion, shifting even now beneath the weight of the present. You've arrived beneath the Thwaites Glacier, sometimes called the Doomsday Glacier. Its name, while dramatic, comes not from fear alone, but from truth. This glacier, roughly the size of Florida, holds the potential to reshape coastlines far beyond Antarctica. Here the bed beneath the glacier slopes downward, inland, not toward the ocean. This peculiar topography, known as a retrograde slope, means that once the glacier begins to retreat, seawater can flow beneath it, more easily lifting and accelerating the ice from below. You hover beneath its massive underside now, where scientists have drilled and sent in remote submersibles, just like the one you might imagine yourself to be: small, quiet, full of questions. The ice here is over 1 kilometer thick, but the contact between glacier and bedrock is weakening. Warm water flows underneath, melting it not from the surface, but from below. This meltwater acts like a kind of slippery lubricant, reducing friction and allowing the glacier to slide faster toward the sea. Thwaites alone is already contributing about 4% of annual global sea level rise. If it collapses entirely, along with its neighboring ice, it could eventually raise sea levels by over 3 meters 10 feet. But this isn't an explosion. It's a slow exhale. It's a process so quiet, so subtle, that to watch it in real time feels like observing a sleeping giant twitch in its dreams. Fractures form, water seeps, ice slumps. Calving fronts where great slabs of ice break into the sea become more frequent, more unpredictable. Ask yourself, what does it mean to measure time in meltwater? What kind of clock counts in drips, in fractures and tides, rising 1 quiet millimeter at a time? The glacier speaks in creaks and groans. It is not unaware of its own motion. Seismic sensors pick up vibrations like whispers moving through stone. These aren't earthquakes in the traditional sense. They are icequakes, sharp, brittle signals of glaciers shifting under stress. And yet there is no panic here, just inevitability, just process. Let your mind wander to the subglacial rivers now flowing beneath Thwaites. These narrow channels, some wider than highways, carry fresh water from the melting base of the glacier out toward the ocean. They carve into the ice like slow scalpels, reshaping the glacier from within. In 2023, scientists sent a robot beneath the glacier and discovered that melting wasn't uniform. It didn't act like warm butter beneath a pan. It melted in ridges and pits, creating an almost lunar surface beneath the ice, a landscape of bumps and troughs and hidden valleys. What shapes these features? The answer is both simple and strange: salt sediment and slow heat from Earth's crust. The geothermal energy rising from the bedrock beneath Antarctica, though faint, adds a layer of complexity. It means no two patches of glacier behave exactly alike. Even now, in this hidden realm, the Earth is alive. You drift slowly beneath Thwaites, sensing its mass, its tension, its memory. This glacier is not just melting, it's negotiating with gravity, with time, with warmth, with the ocean that laps quietly at its feet. And as it changes, so too does the world it holds back. Because behind Thwaites lies more ice, vast basins of it stretching into the heart of West Antarctica. If Thwaites falls, that ice is next. Not all at once, but eventually. This isn't just a story of Antarctica. It's a story of coastal cities, island nations, floodplains, and future maps. The changes happening here deep beneath the glacier will echo in places far from these frozen shores. Still, for now, it's quiet. The glacier breathes in centuries, it sighs in meters. And you floating here are just one moment, passing by softly, gently, without a trace. Let yourself wonder for a moment, is it more humbling or more comforting to know that such vastness can move so silently, that change doesn't always come with thunder, but with patience? Beneath Thwaites you learn the language of slow collapse, the poetry of hidden thresholds, and the deep, deep truth that even the largest things must eventually let go. You drift now through a world on the brink of transition, not chaos, but quiet unraveling. The silence beneath Antarctica has grown softer, more reflective. You're nearing the outer limits of this frozen kingdom, where the last edges of permanence begin to blur, and a new kind of story begins to unfold, not about what has always been, but about what might become. Here we turn to the future of Antarctica, not in cold predictions or dire warnings, but in gentle possibilities. This isn't just a place of melting ice and breaking shelves. It's also a continent of scientific hope, of technological wonder, of cooperation unmatched anywhere else on Earth. At the surface far above your slow glide, there stands a collection of strange structures scattered like small alien habitats. These are research stations operated by over 30 countries, the largest scientific collaboration in the world, bound by the Antarctic Treaty. Signed in 1959, this agreement ensures that Antarctica will remain dedicated to peace and science, free from military use, national claims, or territorial disputes. Pause to think about that. A continent without war, without borders. A place where nations that disagree elsewhere choose to collaborate. It's not perfect, but it's a glimmer. A hopeful blueprint written into the snow. You rise gently toward one of these outposts, now perhaps McMurdo Station, a bustling American research hub on the coast, or the sleek modular curves of the British Halley 6 research station, perched on the Brunt ice shelf, designed to move with the shifting ice. Or even the solar-powered silence of Concordia Station, where French and Italian scientists study the stars and sleep patterns at the coldest, most isolated place on Earth. Beneath these stations, hidden from view, are cables and sensors and radar pulses, tools reaching into the ice and sea, listening for every crack, every melt, every whisper of change. Scientists here drill through kilometers of ice to extract ancient air. They launch balloons to measure solar radiation. They send autonomous drones beneath glaciers, and float remote buoys in the Southern Ocean. They're not just studying Antarctica. They're learning how Earth works, how the oceans breathe, how carbon moves, how planets might behave beyond our own. Yes, Antarctica has become a place to test Mars suits, to simulate space sleep cycles, to train for missions to Europa, Jupiter's ice-covered moon. The frozen stillness here mirrors the silence of space more than any place on Earth. And still beneath it all, the ice watches, listens, waits. You begin to wonder what tools might future scientists use to see into the ice lasers that scan its crystal lattice, nanobots that swim through brine channels, AI systems that model millennia of glacier movement with precision and poetry. Already, supercomputers are helping scientists project future sea level rise. They model different scenarios based on human decisions, how much we reduce emissions, how quickly we act. Some models show Thwaites Glacier retreating rapidly. Others offer slower, more manageable change. The future here is not written. It is sketched in snow, waiting for footsteps. You might ask yourself, will Antarctica always be ice? In tens of millions of years, it may not. Continental drift may carry it north again. Climates may warm or cool, but in our lifetime and many after, it will remain frozen, changing, yes, but still cloaked in white. Yet beneath the ice, life continues to surprise. In subglacial lakes like Vostok and Mercer, scientists have discovered microbial life isolated for thousands or even millions of years. These aren't simple survivors, they're thriving in dark, pressurized ecosystems with no sunlight feeding on minerals and chemical reactions. One day, such discoveries may help us understand how life began on Earth, or how it might exist on icy moons and exoplanets. Antarctica becomes not just a laboratory for today, but for tomorrow's imagination. Still floating beneath you, now pass a probe blinking softly anchored into the ice. It sends back data that will appear on screens thousands of kilometers away, where scientists will stare and smile and wonder. You are surrounded by curiosity, not panic, not despair, but awe. And beyond that, there is the community, not just scientists, but viewers like you. People listening, wondering, drifting off to sleep, with questions tucked behind their eyes. Maybe you've wondered what you can do in your life for this cold, distant world. The truth is simple: knowing it exists, loving that it exists, valuing the silence, the beauty, the balance. That's enough to begin. The future of Antarctica is being written in decisions large and small, in policies and power grids, in electric vehicles, and shared agreements, in voices that rise to say, this matters. And yes, it does. Because Antarctica holds more than ice. It holds the memory of trees, the whispers of ancient air, the slow, fragile dance of glaciers, and the dreams of what kind of planet we still have time to become. So here near the edge, take one last breath with the ice. Let it fill your chest with possibility. The future is not written in fire or stone. It's traced gently in snow. Your journey is nearing its end now. You drift slowly beneath the fading fringe of the Antarctic continent, past where the ice shelves crack into bergs, where the Southern Ocean sighs into distant currents, and where shadows of the past ripple across the seafloor like ink in water. But before you fully return to the surface world, there's one last stop to make a place that lives between extremes, a paradox in itself, Lake Vostok. Hidden beneath nearly 4 kilometers of solid ice, Lake Vostok is one of the largest subglacial lakes on Earth. It's roughly the size of Lake Ontario, stretching over 250 kilometers long and 50 kilometers wide, yet it hasn't seen open air in millions of years. You float now just above its ancient waters, unseen, untouched, completely sealed from the surface, since long before human memory began. And yet, it exists. Liquid water here in a land of ice, a secret ocean beneath a frozen world. How can that be pressure, heat, and time? The enormous weight of the overlying ice creates immense pressure, lowering the freezing point of water. Geothermal heat from Earth's core gently warms the base, and the insulation of all that ice traps the warmth in. It's a fragile balancing act that's lasted for epochs. Scientists didn't even know the lake was there until the 1990s, when radar scans revealed a smooth, reflective surface deep beneath the ice sheet. Since then, explorers and researchers have approached it with reverent caution, wary of contaminating its ancient, isolated environment. Imagine what it holds. In 2012, Russian scientists drilled into the lake, carefully melting a path downward. They reached the upper layer, collecting a sample of water that had been trapped for perhaps 15 to 20 million years. Early results suggested that microbial life might be present, organisms surviving in the dark under immense pressure without sunlight or fresh air. What does life look like in such a place? What does it eat? What does it become? You might ask yourself, if life can exist here, could it exist anywhere? Places like Lake Vostok are not just Earth's hidden gems. They are windows into alien worlds. The icy moons, Europa, and Enceladus, orbiting Jupiter and Saturn, have similar hidden oceans beneath thick crusts of ice. What we learn here beneath Antarctica could one day help us understand life beyond our own planet. Lake Vostok is not alone. There are more than 400 subglacial lakes mapped beneath the Antarctic ice sheet. Some are tiny pockets. Others form networks connected by underground rivers that pulse and move with the shifting weight above. These lakes fill and drain in cycles, rising and falling, subtly like the heartbeat of the ice sheet itself. They're not frozen relics. They're dynamic, alive in their own silent way. Let your mind wander now beneath the glacier into this realm of hidden water and timeless stillness. Picture the sediment at the bottom of Lake Vostok, untouched for tens of millions of years. Every grain of it a record, every layer a page in a book no one has yet read. As you hover above the ancient lake, let yourself feel something rare. Reverence. Reverence for the unknown, for the silence that speaks volumes, for the idea that beneath our feet there is still magic left in the world. Because that's what this journey has truly been about. Not just science, not just ice, but the wonder that comes when we look at the planet we live on, not as something to control, but as something to explore, to cherish, to listen to gently without demand. You've floated with drifting icebergs. You've watched glaciers breathe. You've traced the memory of ancient forests and touched the pulse of deep-sea currents. You've seen what the ice hides, what the ocean carries, and what the future might hold. And now, as you prepare to leave this hidden realm, let the images linger. A continent that sleeps in white silence, a sea that cradles it like a lullaby, a lake that glows in the dark. The world is quieter than we think, but never less alive. And now, let everything slow. Let your breath become steady and soft, like falling snow on ancient stone. The ice has shared its stories with you tonight, not with urgency, but with gentleness, with patience, with the kind of trust only time can offer. Feel how the darkness here is different. It's not empty, it's comforting. Like the shadowed stillness beneath an old tree, or the hush before sleep in a safe, warm room. Let the imagery soften. The icebergs drift into a gentle blur. The glaciers become smooth fields of white, stretching far beyond your view. The winds quiet. The sea, ever moving, seems now to rock you with its rhythm, lulling your thoughts toward rest. The continent fades, not with finality, but with peace, like a candle being gently blown out, one glowing ember at a time. You've traveled far tonight, across frozen plains and under ancient mountains, through forests long gone and waters still undiscovered. You've stood with science, but you've also dreamed with it, imagined what lies beyond the data, felt the heartbeat beneath the frost. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night. Sweet dreams.